I hope you all are fine. I am your math teacher. Let us start our topic, parallel and intersecting lines. Across the line, take a piece of square paper and fold it in different ways. Now on the creases formed by the folds, draw lines using a pencil and a scale. You will notice different lines on the papers. Take any pair of the lines and observe their relation with each other. Do they meet? If they do not meet within the paper, do you think they would meet if they were extended beyond the paper? In this chapter, we will explore the relationship between lines on a plane surface. The tabletop, your piece of paper, the blackboard and the bulletin board are all examples of plane surfaces. Let us observe a pair of lines that meet each other. You will notice that they meet at a point. When a pair of lines meet each other at a point on a plane surface, we say that lines intersect each other. Let us observe what happens when two lines intersect. In figure 5.2, where line L intersect line M, we can see that four angles are formed. We know that angle A and angle B together measures 180 degree because when they are combined, they form a straight angle which measures 180 degree. So, if angle A is equals to 120 degree, then angle B is equals to 60 degree, must be 60 degree. Similarly, angle B and angle C together measures 180 degree. So, if angle B is 60 degree, then angle C must be 120 degree. And angle C and angle D together measures 180 degree. So, if angle C is 120 degree, then angle D must be 60 degree. Therefore, in figure 5.2, angle A and angle C measures 120 degree and angle B and angle D measures 60 degree. When two lines intersect each other and form four angles labeled A, B, C and D as in figure 5.2, then angle A and angle C are equal and angle B and angle D are equal. Check this for different measures of angle A. Using these measurements, can you reason whether this property holds true for any measure of angle A? We can generalize our reasoning for figure 5.2 without assuming the value of angle A. Since straight angles measures 180 degree, we must have angle A plus B is equals to angle A plus angle D is equals to 180 degree. Hence, angle B and angle D are always equal. Similarly, angle B plus angle A is equals to angle B plus angle C is 180 degree. So, angle A and angle C must be equal. Adjacent angles like angle A and angle B formed by two lines intersecting each other are called linear pairs. Linear pairs always add up to 180 degree. Opposite angles like angle B and angle D formed by two lines intersecting each other are called vertically opposite angles. Vertically opposite angles are always equal to each other. From the above reasoning, we conclude that whenever two lines intersect, vertically opposite angles are equal. Such a justification is called a proof in mathematics. Now, measurement and geometry. You might have noticed that you measure linear pairs, sometimes they may not add up to 180 degree, or when you measure vertically opposite angles, they may be unequal sometimes. What are the reasons for this? There could be different reasons. First, measurement errors because of improper use of measuring instrument, in this case a protractor. Next, variation in the thickness of the lines drawn. The ideal line in geometry does not have any thickness, but it is not possible for us to draw a line without any thickness. In geometry, we created ideal versions of lines and other shapes we see around us and analyze the relationship between them. For example, we know that the angles formed by a straight angle is 180 degrees. So, if another line divides this angle into two parts, both parts should add up to 180 degrees. We arrive at this simply through reasoning and not by measurement. When we measure, it might not be exactly so for the reason mentioned above. Still, the measurements come out very close to what we predict, because of which geometry finds widespread applications in different disciplines such as physics, art, engineering and architecture. Now, next is perpendicular lines. If two lines intersect and all four angles are equal, then each angle must be right angle, that is 90 degree. Now, perpendicular lines are a pair of lines which intersect each other at right angle, that is 90 degree. In adjacent figure, we say that line L and M are perpendicular to each other. Now, between lines, observe figure 5.4 and describe the way the line segments meet or cross each other. In each case, with appropriate mathematical words, a point, an end point, the midpoint, meet, intersect, and degree measure of each angle. For example, line segment FG and FH meet at the end point F at an angle 115.3 degree. Are line segment ST and UV likely to meet if they are extended? Yes. Are line segments OP and QR likely to meet if they are extended? No. Here are some examples of lines we notice around. These are the examples. These examples. What is common to the lines in the picture above? They do not seem likely to intersect each other. Such lines are called parallel lines. Now, parallel lines are a pair of lines that lie on the same plane and do not meet however far we extended them at both ends. Name some parallel lines you can spot in your classroom. Parallel lines are often used in artwork and shading. Now, parallel and perpendicular lines in paper folding. Do and learn. Take a plain square sheet of paper. Use a newspaper for this activity. तो बच्चों ये एक्टिविटी आप अपनी क्लास में अपनी क्लास टीचर के साथ परफॉर्म करेंगे और जितने भी ऑब्जर्वेशंस होंगे उनको आप फिल करेंगे. Now, exercise 5.1. Question number 1. Which pair of lines appears to be parallel in figure 5.9 below? Parallel lines. Parallel lines are these two. These are parallel lines. These are parallel lines. And these are parallel lines. These are parallel lines. When we extend them, they never meet each other. तो बच्चों सेम मेथड को यूज करते हुए बाकी के क्वेश्चंस आप खुद ट्राई करेंगे. Now next is transversal. A line which intersect two or more lines at a distinct point is called a transversal. Angles formed when a transversal cuts two parallel lines. Let two parallel lines L and M be cut by a transversal T, forming angles as shown in figure 5.15. We have first is corresponding angles. Angle 1 and angle 5, angle 2 and angle 6, angle 3 and angle 7, and angle 4 and angle 8 are called pair of corresponding angles. Second is alternate interior angles. Angle 3 and angle 5, angle 4 and angle 6 are called pair of alternate interior angles. Alternate exterior angles. Angle 2 and angle 8 and angle 1 and angle 7 are called pairs of alternate exterior angles. Fourth, consecutive interior angles. Angle 3 and angle 6, angle 4 and angle 5 are called pairs of consecutive interior or simply co-interior angles. Theorem: if two parallel lines are intersected by a transversal, then first, the angles of each pair of corresponding angles are equal, that is angle 1 is equals to angle 5, angle 4 is equals to angle 8, angle 2 is equals to angle 6 and angle 3 is equals to angle 7. Second, the angles of the each pair of alternate interior angles are equal, that is angle 3 is equals to angle 5, angle 4 is equals to angle 6. Next, third, the sum of the consecutive interior angles is 180 degree, that is angle 3 plus angle 6 is equals to 180 degree, angle 4 plus angle 5 is equals to 180 degree. Conversely, we have, if two lines are intersected by a transversal such that, first, the angles of any pair of corresponding angles are equal, or the angles of any pair of alternate interior angles are equal, or third, the sum of the consecutive interior angles is 180 degree, then the two lines are parallel. Proof of the above theorem and its converse is beyond the scope of this book. Now, example 1. In the given figure 5.17, L parallel to M and T is a transversal such that angle 1 is equals to 135 degree. Find the measure of each one of the angles, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7 and angle 8. Solution. It is given that angle 1 is equals to 135 degree. Now, angle 3 is equals to angle 1, that is equals to 135 degree, vertically opposite angle. Angle 5 is equals to angle 3, 135 degree, alternate interior angles. Now, angle 1 plus angle 2 is 180 degree. Angle 1 is 135 degree plus angle 2 is 180. Linear pair, so angle 2 is 180 minus 135 is equals to 45 degree. Angle 3 plus 4 also linear pair is equals to 180 degree. Angle 3 is 135, so angle 4 is 180 minus 135 is 45 degree. Angle 5 plus angle 6 is equals to 180 degree, linear pair. 5 is 135, so 6 is 180 minus 135 is also equals to 45 degree. So angle 2 is equals to 45 degree, angle 3 is equals to 135 degree, angle 4 is 45 degree, angle 5 is 135 degree, angle 6 is 45 degree, angle 7 is 135 degree and angle 8 is 45 degree. Now, example 2. In the adjoining figure 5.18, it is given that angle A is equals to 60 degree, CE is parallel to BA, CE is parallel to BA and angle ACB. Now, solution. C is parallel to BA and AC is a transversal. So, angle ACE, angle ACE is equals to angle BAC, that is equals to 60 degree, alternate angles. So, angle ACD is equals to angle ACE plus angle ECD. ACE or ECD, that is equals to 60 degree plus 65 is equals to 125 degree. Now, angle ACB, this angle is 180 minus angle ACD because angle ACB and angle ACD form a linear pair. So, 180 degree minus 125 degree is equals to 55 degree. Hence, angle ACB is 55 degree. Now, example 3. In the adjoining figure 5.19, it is given that OA is parallel to EC and OB is parallel to ED. Prove that angle AOB is equals to angle CED. AOB is equals to CED. CED means angle 1 is equals to angle 3. Now, solution. OA is parallel to EC and OB is a transversal. So, angle 1 is equals to angle 2, corresponding angles. Again, OB is parallel to ED and EC is a transversal. So, angle 2 is equals to angle 3, corresponding angle. From 1 and 2, we get angle 1 is equals to angle 2 and angle 2 is equals to angle 3. So, angle 1 is equals to angle 3. Hence, angle AOB is equals to angle CED. Now, example 4. In the adjoining figure 5.20, AB is parallel to CD and EF is a transversal cutting them at G and H respectively. If GL and HM are the bisectors of the corresponding angles EGB and EHD respectively, show that GL parallel to HM. Solution. Since AB parallel to CD and EF is a transversal, we have angle EGB is equals to angle EHD, corresponding angles. So, half of EGB is equals to half of EHD, that is equals to angle EGL is equals to angle EHM. But these are corresponding angles made by the transversal EF on the lines GL and HM. So, GL is parallel to HM. Now, example 5. In the adjoining figure or the given figure 5.21, EF parallel to GH, angle EAB is 65 degree and angle ACH is 100 degree. Determine first angle ABC, ACB, BAC and CAF. Solution. First, EF is parallel to GH and AB is a transversal. So, angle ABC is equals to EAB, that is 65 degree, alternate angle. Now, second, CA stands at C on GH. So angle ACB plus angle ACH is 180 degree, or ACH is equals to 100 degree. So angle ACB is 180 minus 100 is equals to 80 degree. Now third, EF is parallel to GH and AC is a transversal. So EAC angle is equals to angle ACH, that is equals to 100 degree, alternate angle. Angle EAB plus angle BAC is 100 degree, or EAB is 65. So angle BAC is 100 minus 65 is equals to 35 degree. Now fourth, now EF is parallel to GH and AC is a transversal. Therefore angle CAF plus angle ACH is 180 degree, that is angle ACH is 100 degree. So angle CAF is 180 minus 100 is equals to 80 degree. Hence angle ABC is 65 degree, angle ACB is 80 degree, angle BAC is 35 degree, angle CAF is 80 degree. Now example 6. In the given figure 5.22 show that CD parallel to EF. Now solution, we have angle BAD is equals to angle BAE plus angle EAD, that is 40 degree plus 35 is equals to 75 degree, or angle BAD is equals to angle CDA, that is 75 degree, but angle BAD and angle CDA are alternate interior angles. So CD parallel to AB. Again angle BAE and angle AEF are co-interior angles. Therefore AB parallel to EF. AB parallel to EF, AB parallel to CD. So CD parallel to EF. From 1 and 2 we get CD parallel to AB parallel to EF. Hence CD is also parallel to EF. Now example 7. In the given figure 5.23, two lines L and M are intersected by a transversal T such that angle 1 is equals to angle 2. Is L parallel to M? Give reason. Solution, it is being given that angle 1 is equals to angle 2, but these are alternate interior angles, and we know that if the angles of any pair of alternate interior angles are equal, then the lines are parallel. Hence L parallel to M. Now example 8. In figure 5.24, parallel lines L and M are intersected by the transversal T. If angle 6 is 135 degree, what are the measures of other angles? Solution, angle 6 is 135 degree. So angle 2 is also 135 degree because it is the corresponding angle of angle 6 and the lines L and M are parallel. Angle 8 is 135 degree because it is the vertically opposite angle of angle 6. Angle 4 is 135 degree because it is the corresponding angle of angle 8. Angle 2 is 135 degree because it is the vertically opposite angle of angle 4. So angle 2, angle 4, angle 6 and angle 8 are all 135 degree. Angle 5 and angle 6 are linear pair together. They measure 180 degree. If angle 6 is 135 degree, then angle 5 is 180 minus 135 degree is equals to 45 degree. We can similarly find out that angle 1, angle 3, angle 7 measures 45 degree. Now example 9. In figure 5.25, lines L and M are intersected by the transversal T. If angle A is 120 degree and angle F is 70 degree, are lines L and M parallel to each other? Solution, angle A is 120 degree, so angle B is 60 degree because A and B form a linear pair. B is the corresponding angle of angle F. If L and M are parallel, angle B should be equal to angle F. However, they are not equal. Therefore, lines L and M are not parallel to each other as the corresponding angles formed by the transversal T are not equal to each other. Now example 10. In figure 5.26, parallel lines L and M are intersected by the transversal T. If angle 3 is 50 degree, what is the measure of angle 6? Now solution, angle 3 is 50 degree. Therefore, angle 2 is 130 degree because angle 2 and angle 3 form a linear pair and linear pairs always add up to 180 degree. Angle 2 and angle 6 are corresponding angles and they need to be equal since line L and M are parallel. So angle 6 is 130 degree and angle 3 and angle 6 are called interior angles. Is there a relation between angle 3 and angle 6? You could try to find the relationship by taking different values for angle 3 and see what angle 6 is. Once you find a relation, try to justify it to prove that this relation holds always. You will find that the sum of the interior angles on the same side of a transversal always add up to 180 degree. Now, example 11. In figure 5.27, line segment AB is parallel to CD and AD is parallel to BC. Angle DAC is 65 degree. Angle ADC is 60 degree. What are the measures of angle CAB, angle ABC and angle BCD? Solution. Let us observe the parallel lines AB and CD. AD is the transversal of these two lines. We know that the sum of the interior angles formed by a transversal and a pair of parallel lines add up to 180 degree. So, angle ADC plus angle DAB is 180 degree. Angle ADC is 60 degree. So, angle DAB is 180 minus 60 is 120 degree. Can we find angle CAB from this? Angle DAB is equals to angle DAC plus angle CAB, that is 120 is equals to 65 degree plus angle CAB. Angle CAB is 120 minus 65 degree, that is equals to 55 degree. Let us observe the parallel line segments AD and BC. They are intersected by a transversal CD. So, angle ADC plus angle BCD is 180 degree because they are interior angles on the same side of the transversal. Since angle ADC is given as 60 degree, so angle BCD is 120 degree. Similarly, we find angle ABC is 60 degree. Therefore, in figure 5.27, angle CAB is 55 degree, angle ABC is 60 degree and angle BCD is 120 degree. Now, exercise 5.2, question number 1, find the angles marked below. Now, these are parallel lines and this is the transverse. This is 48. So, angle A is also equals to 48 डिग्री. तो बच्चों सेम मेथड को यूज करते हुए बाकी के पार्ट्स आप खुद ट्राई करेंगे. नाउ क्वेश्चन नंबर 2, फाइंड द एंगल्स रिप्रेजेंटेड बाय ए. सो दिस इज 42, दिस आल्सो 42 and this is linear pair. 180 minus 42 degree is equals to 10 minus 2 is 8, 7 minus 4 is 3, that is 138 degree. So A is equals to 138 डिग्री. तो बच्चों सेम मेथड को यूज करते हुए बाकी के पार्ट्स आप खुद ट्राई करेंगे. नाउ क्वेश्चन नंबर 3, इन द फिगर बिलो व्हाट एंगल्स डू x and y stands for? नाउ फर्स्ट x, सो दिस इज द 90 डिग्री, दिस इज 90 डिग्री, दिस इज ऑल्सो 90 डिग्री. तो 90 माइनस 65 डिग्री इज इक्वल्स टू 5, 8 minus 6 is 2. This is 25 degree. So, x is also equals to 25 degree vertically opposite angle and this is the transversal. This is the transversal. This is the transversal and this is 180 degree. Y plus this is 180 degree. So, this is the transversal. So, this is 25. So, this also 25 degree. So, 180 minus 25 degree is 10 minus 5 is 5, 7 minus 2 is 5. So, y is 155 degree. तो बच्चों सेम मेथड को यूज करते हुए बाकी के पार्ट्स आप खुद ट्राई करेंगे. Now, next is parallel illusions. There do not seem to be any parallel lines here, or are there? What causes these illusions? When a pair of lines are not parallel to each other, the corresponding angles formed by a transversal can never be equal to each other. Now, next is drawing parallel lines. Draw a line L with a scale. By sliding your set square, you can make two lines perpendicular to line L. Are these two lines parallel to each other? How are we sure that they are parallel to each other? What angles are formed between these lines and line L? Since we used a set square, the angles measures 90 degree. The position of the lines is different, but they make the same angle with L. If line L is seen as a transversal to the two lines, then the corresponding angles measures 90 degree. As we know, these are corresponding angles and they are equal. We can be sure that the lines are parallel. Draw two more parallel lines using the long side of the set square as shown in figure 5.2. 4, 3. Now, do and learn. By paper folding, you can form the parallel lines. Do this activity in your class. Now, exercise 5.3. First, can you draw a parallel line to L that goes through point A? How will you do it with the tools from your geometry box? Describe your method. तो बच्चों, ये क्वेश्चन आप अपनी क्लास में अपनी क्लास टीचर के साथ परफॉर्म करेंगे अपने ज्योमेट्री बॉक्स के टूल्स के साथ. तो बच्चों, सेम मेथड को यूज करते हुए बाकी के क्वेश्चंस आप खुद ट्राई करेंगे. तो बच्चों, आई होप आपको चैप्टर समझ आया. इसका रिवीजन आप खुद करेंगे.